clothes. They are getting dried because of solar energy. Solar energy, the energy from the sun. Solar energy is used in various ways, but we don't realize that it is solar energy that is being used. During photosynthesis, plants use solar energy to make food. We use solar energy to dry or heat food. Solar energy is also a natural source of light. The sun emits a lot of energy. However, the atmosphere and the clouds absorb 50% of this energy. So, only a portion of the total emission reaches the Earth's surface. The energy that reaches the Earth is spread over a wide area. So, we use devices called solar collectors or solar cells to make solar energy more concentrated. The energy is then changed into a more usable form. This energy can also be stored. The solar cooker is a device used for making food. The solar cooker is made up of a wooden box with a glass and mirror. Did you notice that the box is painted black from within? This is because a dark-colored surface absorbs more light when compared to a light-colored surface. So, food is also placed in black containers and is kept inside the solar cooker. When the cooker is placed in direct sunlight, the mirror reflects the sunlight. The solar energy is transformed into heat, and the food gets cooked in some time. The glass helps in retaining the heat inside the box. Some of the other solar devices used are solar dryers and solar water heaters. Do you know that solar energy can also be converted into electricity? Solar cells are interconnected to form a solar panel. When the sun's radiation falls on this panel, solar energy is converted to electricity. Such panels are placed on the roofs of houses. These panels are also used in calculators and video games. Solar energy is used to generate electricity in satellites and spacecrafts. Research shows that the sun has been emitting energy for the last 5 billion years and will continue to do so for about 5 billion years. If suitably tapped, solar energy has the potential to satisfy all future energy needs. Solar energy does not cause pollution. Therefore, it does not have any negative impact on the environment. Moreover, in backward areas, it is easier to set up solar devices when compared with most of the other energy devices.
Energy in the form of fuel for our day-to-day use. You must have heard or read about how Earth's natural energy resources are being rapidly depleted. Scientists are searching for new ways of generating energy. In this quest, scientists have started devising ways of generating electricity from the oceans. Seawater crashes on the shore in the form of waves. Can you guess which form of energy these waves have? Waves are in motion and have kinetic energy. Let us find out how this and other forms of energy from the sea can be converted to electrical energy. Watch this buoy floating in the water. You can see it go up and down as each wave passes under it. Now then, as the buoy completes one oscillation as the wave passes, is it moving closer to the shore? No, the buoy does not move closer to the shore. It remains at that same point and oscillates as the waves pass. The oscillatory motion of the buoy can be used to rotate the shaft of a dynamo. The dynamo in turn can generate electricity. However, wave energy has one limitation. In order that sufficient energy can be drawn from the waves need to be strong enough. The moon exerts a gravitational force on the earth and everything on it. This produces tides along the shores. During high tide, water level at the shore rises, while during low tide, the water level falls. Most places on the earth experience 2 high and 2 low tides in a day. This movement of water during the tides is used to produce electricity. A tidal dam or barrage is constructed near an estuary. The dam has a turbine located at the bottom. During high tide, water enters the other side of the dam. The movement of the water turns the turbine and electricity is generated. After the high tide, the gates are closed. As low tide begins, the gates are opened and the water is released. This turns the turbines, but in the opposite direction this time. Is tidal energy renewable energy? Explain. Yes, tidal energy is a renewable source of energy. The moon will always be there to create the tides in the oceans on the earth. The sun heats the waters of the oceans. This increases the temperature of the surface water. However, deep below the surface, the water is still cool. The difference in the temperature creates what is known as ocean thermal energy. However, this temperature difference should be of at least 20 degrees Celsius. Scientists and engineers have developed devices to harness this energy. Such devices or plants are called ocean thermal energy conversion power plants. The power plant uses a liquid such as ammonia. It boils ammonia from the heat of the surface water. The vaporized ammonia is then passed over a turbine under high pressure. The turbine spins and generates electricity. The ammonia is then brought to the condenser. Here the ammonia is cooled using the cooler waters of the deep sea. It is then reintroduced into the cycle. This cycle is repeated to generate electricity throughout the day. How is the OTEC power plant able to generate electricity at night when there is no sun to heat the water? OTECs are set up in tropical waters. There is hardly any change in temperature in the water in these tropical areas. Source of thermal energy is renewable and non-polluting. The naturally available steam is utilized at the power plant to rotate the steam turbines. Geothermal energy is thermal energy from the earth. The earth's core is very hot. When it rains, some water is collected over the underlying rocks. In certain regions on Earth, the hot, molten part of the core is close to the surface. It heats these rocks, which in turn heat the water over them. That is how geysers and natural springs form. In some areas, water is pumped down to hot rocks of this sort to produce steam. This steam rises up under a high pressure in pipes. It is passed over the turbines at the power plant to produce electricity. You may have heard stories of the two world wars from your elders, or may have watched programs about them on television. One of the major events of the Second World War was the bombing of Hiroshima and Nagasaki by the Americans. For the first time in the history of mankind, an atomic bomb was detonated, first over Hiroshima and then over Nagasaki. The bombs had a power many times greater than ever seen before in a man-made explosion. How were these bombs able to generate such tremendous amounts of energy? It is nuclear energy. As we proceed, we will learn more about nuclear energy. Nuclear energy originates from the nucleus of an atom. There are two types of nuclear reaction. In one of the reactions, a larger nucleus disintegrates to form smaller nuclei. This reaction is called nuclear fission. And in the second, two smaller nuclei fuse to form a larger nucleus. This reaction is called nuclear fusion. Splitting or fusing of nuclei produces a difference in the mass of the reactants and the products. This mass is converted to energy. Nuclear fission was first observed in 1939, when a uranium nucleus was bombarded with a slow-moving neutron. In nuclear fission, the energy is released in the form of the kinetic energy of the newly formed particles and as radiation. Note that in this animation, the particles are still, for the purpose of our study. In the nuclear fission of uranium, an atom each of barium and krypton is formed. The reaction also gives out 3 neutrons and radiation in the form of gamma rays. Using Einstein's mass-energy equivalence relation, scientists have determined the total amount of energy released in the nuclear fission of uranium. One uranium nucleus produces 190 million electron volts of energy, where an electron volt is a measure of energy. It has been found that if 1 gram of uranium undergoes fission, then it releases 4.86 into 10 to the power of 23 million electron volts. This amount of energy is equivalent to the energy released by exploding 20 tons of TNT. If nuclear fission reactions are left unchecked, they result in a chain reaction. The 3 neutrons that are given out in the fission reaction excite other uranium atoms and cause further fission. This process continues, releasing tremendous amounts of energy and radiation. What could be the use of such a destructive reaction? The principle of the uncontrolled chain reaction formed the basis of the atomic bomb. A chain reaction takes place in the fission of uranium because of the 3 neutrons that are released in the fission reaction. If we restrict 2 of these 3 neutrons, we can control the fission reaction. Cadmium rods are used to absorb the excess neutrons. This way, the reaction continues in a controlled and more fruitful manner. How are controlled fission reactions useful? Controlled fission reactions can be used in nuclear reactors. The heat produced in the reactions can be used to produce electricity. Nuclear energy is released when 2 smaller nuclei combine or fuse to form a larger nucleus. In this process, an enormous amount of energy is released.